Joshua, were you able to do any of these? If not, it's okay.
I um
Or even if you did, baka hindi mo pa naisulat, okay lang. I would rather see what you've written down. So we can talk about these next time.
abo.
Okay? Sige. Um, let's review some of the things that we did. One thing that I want to avoid though is just going through topic and then next topic and then next topic and then next topic. Because we build mathematical maturity not so much by exposing ourselves to these topics, but really by practicing. So I feel like, kunwari, if I discuss everything I know about trigonometry this week, and then next week everything I know about exponential functions and logarithmic functions. That wouldn't really be the best thing to do. Okay? Kasi dapat dapat mag-practice ka. Although at the same time I'm giving you flexibility with the exercises. So you still have the exercises from the other lessons and also in trigonometry. So just do them when you find the opportunity. And I know you are. So for now, there are new things that I uh, am going to talk about if we have time for that. But let's also
Kami,
uh,
minahal po ako
just go
dito.
ahead.
Tawag po dito salty circles eh. Meron nata, so tinanong ko po, there's actually a relationship between DEF tsaka ABC. But then, wala, since then, parang nag-reply po ako, wala pa pong sagot.
So you ask someone about this issue about DEF and ABC.
Opo, I asked sa Reddit po, is there a relationship
Sorry, who did you ask?
sa Reddit,
It's a bit echoing. Sorry, Sina.
saka sa Math Stock Exchange. So, meron daw po
Oh, okay.
relationship between DEF and ABC, but,
Is it is it in terms of the area?
wala pa pong sinabi. Sinabi lang po, there
All
is,
right, all right, all right. Sige, if they observe something, if they point something out, I'd be interested to know kasi ang dami-dami itong mga relationships eh. But after them giving it to us, let's try to prove it. Okay? So the might it would be nice if they could give us a claim that they say, oh, the area of DEF is so and so, or if you look at the altitudes of DEF, they will intersect in this particular point. So that we could prove. I'm really also interested in seeing that. It could jog my memory as soon as I hear what they have to say.
opo.
Okay, so it's there. Um, so you talked about the law of sines. Actually, meron pang extended law of sines. We will get there eventually when we discuss more geometry. What else did we talk about? What else did we talk about? The angle bisector theorem. So the angle bisector AD divides the opposite side into segments M and N proportional to C and B, the two other given sides. So we actually prove that. And then the law of cosines. So the law of sines and the law of cosines. So we solved the triangle, and these were miscellaneous applications. So these four bullet points, some of them use the sine law, some of them use the cosine law, some of them don't. So halo-halo na.
Sir, meron po kayo
Okay.
nakitang
What?
problem. Sabi,
Yeah, go ahead. What's
this
this?
is sometimes called the law of tangents.
Okay, what does it say?
Gusto niyo po sulit ko yung problem? Sulit po ni Joshua yung problem?
Yeah, sure. Oh, or the equation.
Paano po nga
Yes.
mag-annotate? No, wala pong option.
Paano mag-annotate? Oh, here in Zoom, hold on. I think that there should be paano ba ng annotate? Ganito. Or you're a co-host, right? Are you able to share?
Opo.
Share tapos when you go to share, do you see whiteboard?
Opo.
Try that.
Sure. Yes, I can annotate immediately.
All
Okay.
right. Or rather, you can write something down.
So,
Yes po.
huh?
Show that in triangle ABC.
Ay.
ABC,
Well, the usual naming system.
comma. Then we have, sulit mo lang, tangent.
Oh, cool. All right. This is fun. Let's prove this, okay? Have you seen the proof? Nakita mo no proof?
Hindi pa po, hindi pa po.
Hindi, try natin. Okay, so I think I've seen this before. I mean, minsan mga nakikita ko exercises in the book. So I'm gonna take over now. So given triangle ABC with the usual naming system, so this is A, this is B, and then this is C. Then we have tangent of A minus B over 2 divided by the tangent of A plus B divided by 2 is equal to A minus B over A plus B. Now, of course, you could also conclude based on this relationship between some of the angles and sides that tangent of B minus C over 2 divided by the tangent of B plus C over 2 is equal to B minus C divided by B plus C. Then, of course, in the first, you could have stated it as tangent of B minus A over 2. And then the right side's numerator would have been B minus A. So basically what this is, just like the law of sines and the law of cosines, it's an equation which some of the sides and angles must satisfy. So kumbaga, you have some angles and sides and they do not satisfy this equation, then there's something wrong. Such a triangle cannot exist because the parts should satisfy this. How would I prove this? I would start with the right side. Okay, so an attempt at a proof. I'm going to start with the right-hand side.
That looks
A minus B.
That looks that looks more simple.
Yeah, it is simpler, although I did say back then that typically we start with whichever is more complicated. But the reason I'm starting with the simpler side is because I'm thinking of using the law of sines. A over sine of A is equal to B over the sine of B. So I am going to replace B. So using this equation from the law of sines, B is equal to A times sine of B over the sine of A. And then A plus B is going to be A plus A times sine of B over the sine of A. All right. So the reason why I decided to start with the right side is because I was able to see that this is something that I could do. And note how in the numerator, we now have A as a common factor, A, and then that's 1 minus sine of B over sine of A. And then in the denominator, A times 1 plus sine of B divided by sine of A. So, hey, I can cancel out anything which involves the sides. So now the target is tangent of A minus B over 2 divided by tangent of A plus B over 2. Note how the left-hand side involves only the angles. And look at what we now have. It involves only the angles. And which angles? Precisely those two angles, A and B. Okay, it's precisely those two angles na kailangan natin. So parang the target kasi on the right side, pure sides, on the left side, pure angles. So if you're going to show them to be the same, either you start with the right side, pure sides, i-convert mo for them to become angles. Or you start with the left side na puro angles, and then i-convert mo para maging sides. Now, right now, my options are the law of sines and the law of cosines. Kaso nga lang ng law of cosines, may mga squared quantities eh. And dito naman kasi a minus b over a plus b, walang squared quantities. So I'm going to avoid the cosine law. That's what led me to the sine law. The reason why I'm saying that is I'm guiding you through my thought process. As I'm saying, this is an attempt at a proof. I have not proved this before, but if it was me, this is how I would go.
Opo.
All right, this is how I would do it. I'm going to clear fractions because denominators are evil, di ba? So let's multiply by sine of a. Para lang mas malinaw, mas suabe, it's nicer. Sine of a minus sine of b divided by sine of a
Hey.
plus the sine of b. Okay. Now, ang kailangan natin ngayon ay we have here the difference of two sines and then the sum of two sines. What this reminds me of are formulas. I don't remember the exact formulas for, but I've seen them before and I feel they could help. What formulas am I referring to? Ito. We discussed it, nope, not last Feb 1, but sometime end of January. I'm gonna scroll and see if it's here. I feel like it's one of the exercises I asked you to do. Ito. Remember this. Remember this exercise.
Huh.
Probably ba yan?
Opo.
You know what it reminded me of? Look here at what we have on the left side. Sine something plus sine something. In fact, the much more general equation that might be helpful is this. You see on the right side, the sine of something plus the sine of something. And I'm going to do something you like me doing so much.
The hint has been given. It is
Uh,
sound the alarm.
okay, it has to happen. Yeah, sound the alarm. All right. Okay. Ganito. Let me rewrite it in a way that would be less confusing. Kasi right now we're using A and B for the side lengths. And but in this equation that I just copied, A and B can be thought of as angles. So let me rewrite this in terms of
You cannot copy paste anymore.
okay. I can't copy paste anymore, but I'm going to hold on. Okay, do some editing. Ito nga lang, if I copy paste from a different page, it's laggy. So I mean, I copied it just so I could. I don't have to worry trying to remember what it is, but okay, I'm gonna write it down. Sine of x cosine y multiplied by 2 is equal to sine of x plus y plus the sine of x minus y. In fact, here's what I'm thinking of doing. I'm thinking of applying this on the denominator. So let me put this inside a box. Okay. So you see how we have on the left side the sine of x plus y and the sine of x minus y. And then we can write this as 2 times sine of x times cosine of y. But what are x and y? If we match it with the denominator, we want x plus y to be equal to this a and this x minus y to be equal to this b. Okay. And then if you solve for x and y, what are we going to get?
2x equals a plus b.
So x is equal to
A plus b over 2. No,
a plus b over 2.
It looks too much like what is going to be proved.
Yeah. Okay. Why? No, no, no. It's yes, yes, yes. What about y? It's gonna be
A minus B over 2. Why? I
a
see
minus
it
b
now.
over 2. You see it now? So here's what's gonna happen. It's supposed to be 2 times the sine of x, which is the sine of a plus b over 2, times the cosine of y, the cosine of a minus b over 2. All right. So that's the denominator. Now we are inspired by what we just used here, that formula inside the blue box, because it's sine of something plus the sine of something. Now, the numerator though is the sine of something minus the sine of something. So let's see, perhaps we could come up with a similar formula. What is the sine of x plus y minus the sine of x minus y? Now, the left side is not something I have committed to memory. So this is what I've been telling you before. You don't have to remember everything, but you can, with confidence, derive the tools that you need. Okay, sine of x plus y minus sine of x minus y equals ang sine of x plus y, sine of x cosine of y plus sine of y cosine of x. And then what we are subtracting, sine of x minus y. Sine x cosine y minus sine y cosine x. What's the result?
Oh, it's 2 sine y cosine x.
2 sine y cosine x. So that is this other formula that we need.
Oh,
2
no.
sine y cosine of x. This is our second formula. This is becoming too colorful. Let me use the same. Okay, not exactly the same color. Okay, so now in the numerator, sine of a minus sine of b, but we are still going to match x plus y with a and x minus y with b, so that in that case,
It will become
this equation.
sine over cosine, and the other one will become cosine over sine.
All right, so ito meron ng 2 sine of y. I think you got it na, a minus b over 2. And then cosine of x, a plus b over 2. And then I think you can now see where this is headed. Kill the 2's. Okay, and then ito, sine of a minus b over cosine of a minus b is what? Tangent of a minus b over 2. And then now from the level of the denominator, sine of a plus b divided by cosine of a plus b is tangent of a plus b over 2.
What?
Equals, and this is the left-hand side. And we have proven. You like that? But ito, so I wanted to demonstrate that to you. Kasi, look, it is very much all right if when you look at a problem, you don't know what you have to do. And it takes experience, gaining confidence. So much so that if I wasn't able to do this, you know what? I'm gonna be okay. Sasabihin ko, ay Joshua, hindi ko maisip. Try kong isolve ito later. But the thing is, if you're confident, if you're level-headed, you're not gonna be rattled. And if you're not gonna be rattled, it makes it easier for you to recall, to remember the things that you have seen and done before. So I demonstrated the things that I was reminded of. That comes with practice. Now, if I was given these two equations, I think I would be able to deduce these two equations, no sine of x plus y plus sine of x minus y. But what helped me here is the fact that I have seen this before. And why have I seen this before? Because I have solved this before. And so solve, solve, solve. This ties in with what I said earlier. It makes no sense. There really is nothing to be gained if I'm going to finish trigonometry just for the sake of starting exponential and logarithmic functions next week. Kasi ma-overwhelm ka lang. What we need is confidence in doing these things. It takes time, but you're on a you're in a good path towards that. Okay?
Wow.
Okay. So yeah.
Ang galing po. Ang
So
galing.
that's the parang law of tangents or tangent law. I think I've seen this before, but it does, kunwari, if you're gonna give a formula that's to be named the law of tangents, this is a good candidate
Okay po.
for what the law of tangent would be. Law of tangents, the tangent law for triangles. All right.
Cosecant law and second law. Cotangent law.
Oh, ganito. Cotangent law. Baliktarin natin. Okay. Cotangent A plus B over 2 divided by cotangent of A minus B over 2. Ayun, may cotangent law na tayo, Joshua.
I realized din pa yung second and cosecant are just the reciprocals of the cosecant.
Yeah, oh. Ito medyo doable pa kasi hindi talaga siya it's not the reciprocal of anything. Okay. What I have in mind are some exercises from that illustrate things that we've already seen before. I'll just go ahead with the statement of the problem.
Kaya po hindi po natapos
Yes.
ang mga problems. I was thinking, ang ginawa ko po sa kanya, parang pina-review ko po yung alam niya para ma-integrate sa mga tinuro niyo po. So sabi ko para mag-connect yung mga concepts and ideas.
Yeah. Okay. That's a worthy strategy. Nung connections between different things. So actually it's something that we did earlier, diba? This problem that we were able to connect it. So it's these connections that you need to make.
Opo.
Labo.
All right. So again, okay lang na hindi pa na-solve. Okay. In triangle ABC, segments AD and AE trisect
What?
BAC. Trisect as opposed to bisect. When something bisect.
Bisection impossible? Using straight edge and compass?
Yes, but we're not using a straight edge and compass. But the thing is, an angle can still be trisected. And they don't use a compass, use a protractor. But you're right, you can't use just a straight edge and compass to trisect an angle. So if we're talking about construction exercises.
Oh no.
All right, so this is given. And then suppose AB equals 6, AD equals 3, AE equals, you know what, para hindi tayo mag-decimals, let me just make this 60, 30, and then AE is 27, AC is 38, and DE is 18. In what I wrote down, it was originally 6, 3, and then 2.7. Let's avoid decimals, so ganito na lang. Okay, find the length of BC. So of course, we have to first draw what's going on. So we have triangle ABC. And then it's angle A, it's angle BAC, which is being trisected. So I'm going to try to draw that a little bit larger. So this is congruent to that, and that's congruent to that. AD and AE, so drawn from vertex A. Now, whichever is D and E, hold on, sorry. I should say where D is closer to B than to C. So kasi meron tayong trisection points here. So one of them is D and the other is E, which is which? D is closer to B. So therefore, this must be E. So observe based on the wording that what we are bisecting is the angle itself. Some students would assume that, oh, this is X, and this is X.
Hindi po.
Nope.
Kaya nga po hindi
Hindi,
po
di
siya
ba?
pwede straight edge and compass. Meron po akong ginawa pong proofs, I forgot when. Ano, I remember po, I proved po by it's impossible to construct.
Nung sa angle
Opo.
or sa seg. All right, okay. But okay, so let's write down that the length AB is 60, AD is 30, AE is 27, AC is 38, DE is 18. Find BC. So even if we don't complete the solution, just describe to me your game plan, your strategy, whatever it is you're thinking.
Uh, okay. So
So from B to
I
C.
actually have none, but I will try. Uh, But you can get the other side using law of sines. Is that possible? Wait. There's basically you're just going to find BC.
Mm-hmm.
To find BC, you need to find BD and EC. A triangle ADE is already given, so you already have a template for what AEC and ABD are. AD. All sides are given. So is it possible for me to find APC? I remember this sort of problem.
Mm-hmm.
18 over whatever DAE is. The sign of, am I doing this correctly? Yeah, the law of sines po. So 18 over whatever the sign of whatever DAE.
Let's call that theta.
Opo, let that be theta. So 18 over sine theta should be equal to EC over sine theta. No matter what
EC over sine theta. But then you seem to be saying EC is going to be equal to 18. I think you're using the law of sines here. However, you can't because 18 and the theta that you mentioned, you're looking at triangle DAE, but EC over sine theta, you're looking at EAC. So DAE and EAC are the same triangles. Sorry, they're different triangles. So you cannot really conclude that.
So 18 over DAE is equal to 27 over ADE.
Okay, you're using 18 over sine theta equals 27 over
ADE. Sine ADE.
ADE. All right, so ito no ADE. So I see that.
So then that
Okay.
So
Sine.
wait. Actually, I don't think it's supposed to be. I should be using sine ADE because it's actually not related to AEC. Maybe we should be using AED, which is supplementary to AEC. Okay, so 18 is equal to 30 over sine AED. And then from there, over sine. Okay, so 38 over sine AEC, which is 38 over sine 180 minus AED, should be equal to EC over sine theta. Oh, maybe baka po na there's a little misunderstanding. It's 38 po over wait lang.
Gusto mo magsulat?
180 minus an angle obtuse or
Mhm.
not is just AED anyway.
Uh, Again, an angle and its supplement have the same sign.
Okay, I see. So,
Actually, try mo to.
what could I possibly do now?
Kasi this is
Uh,
correct. This is also correct.
they are they are proportional. They are, if we take the ratio, 30 over
Mhm.
38. 30 over 30, 30 is to 38 as 18 is to EC, I think. Yeah, it should be like that. As so now we can solve. I think
We can solve for EC.
30 over 8.
Okay. Although, let me point out, Joshua, in arriving at this equation, you could have considered the following: A,
Oh,
B,
angle bisector
C.
theorem.
Yeah, E.
Oh, it's technically the
Okay.
angle bisector theorem. I just proved it
30,
over.
38, 18, EC. All
I see,
right.
I see, I see. So we could do
Okay.
another triangle, AEB.
Yeah. Okay.
So
But
F.
see how even if you did not know that angle bisector theorem, it what you know allowed you to end up with the same thing, with the same conclusion anyway. All right, so that's why I didn't stop you there. All right, I wanted to see if you'd be able to find your way.
EC is
Okay.
equal to 22.8.
All
Okay.
right, so ganito. So EC over 38 equals 18 over 30. So that allows us to solve for EC. How about BD?
BD is the other one. It's the
Yeah,
other
give
one.
me an equation
So
involving BD.
18 over 18 over 27 equals whatever BD is over 60.
Yeah, and so you could solve for EC and BD. I know you could do that. Therefore, BC is equal to BD plus 18 plus EC, and that's it. All right.
Abo.
Okay. Um, I wanted to talk about the what else? Hey, so this is not totally exactly related to the law of sines and the law of cosines, but so you know how for some special angles, 30 degrees, 45 degrees, and 60 degrees, we can find their trigonometric function values exactly. And then for other angles which are obtuse or negative, kunwari at 120 degrees or 135 degrees, we can find their trig function values because we just need to look to use their reference angle, 60 degrees and 45 degrees. So then it's just this decision, are we going to put a negative sign beforehand, depending on the quadrant and depending on the trigonometric function. But ultimately, you have the trio of 30 degrees, 45 degrees, and 60 degrees. Joshua, have you seen the trigonometric function values of 36 degrees and 72 degrees?
So I was thinking po kasi ganito po, diba? How could you possibly find yung mga ganun po, yung mga, ano po tawag dun? Wait lang. 36 degrees. This is 360 divided by 10.
Oh,
So, it's the inner, it's the inner sides of a decagon. It's the interior angle of a regular decagon.
uh, 36 degrees. So yeah, I suppose you could situate it vis-a-vis a decagon, although that doesn't really give us a specific game plan how to find cosine of 36 degrees exactly. Well, sure, we could use a calculator. Anyway, I wish to raise that as a rhetorical question. All right. Because, for example, 15 degrees, you can use the fact that this is 30 degrees over 2.
Opo.
All right, may mga half angle formulas
I
tayo.
was actually
Also for 22.5 degrees, half na. Sorry, go ahead.
Wait lang. Let me see po.
What I would like to do,
I just end up with 30. I was thinking po, how could you possibly find, is it possible to find po yung ganun nga po, the sines and cosines and tangents, the trigonometric functions of kumbaga irregular angles?
I would say not all angles. What I would like to demonstrate to you, because it is not as well known, is how to determine the sine and cosine of 36 degrees and 72 degrees. It's not mandatory, all right? It's but I think you'd be able to appreciate it. The first time I saw this as a student, I really thought it was cool. How they were, how someone was able to devise a way of finding exactly the sine and cosine of 36 degrees. Actually, as soon as you know sine and cosine for 36 degrees, 72 is double that. So, you could go on ahead. So, ganito. The strategy is to consider the following triangle. The following isosceles triangle whose vertex angle is 36 degrees. Okay, because if that's 36 degrees and this is an isosceles triangle, in particular, this side length in orange is equal to this side length. Now, Joshua, tell me, what is the base angle? What are those two base angles equal to?
Oh, two base angles. This is a segment of a pentagon. No, this is a segment of a decagon. What's that?
Actually, this is just a triangle. What is this angle here?
Here angle. What's that angle? You know what? I give up.
This one.
72.
180.
Oh, it's this 30. It so happens that 36 and 36 and 72 po. Yung nasa triangle na yan.
All right, so it's 72 here and 72 also up here. So let me write 72 here and also 72 down here. Oh no.
Oh
Okay.
no, the undo option.
Okay, so this is 72 degrees. But I am going to do not just this, but something also magical. I'm going to draw the angle bisector here. But Joshua, if that was 72 degrees there and it's bisected, what are each of these two smaller angles? They're going to be 36, right? 36 degrees here, 36 degrees here, because I mean this to be the angle bisector.
Oh, the other one naman po will become 72. Wait.
Oh.
This will become fractal.
So this is 72 degrees. But at any rate, here's what's going on. We have a lot of isosceles triangles. Oh no. Sige na nga, hindi ko na erase ng orange. No, wait, I want to erase. Okay, you know what? I'm gonna retain the orange segment. Okay, ganito. Let me draw this altitude. And don't worry, I'm not gonna divide 36 degrees anymore. Okay. I think it's time to label some of the points here. A, B, C, D, E. Okay. So why did I draw the perpendicular, the altitude BD? Because now I have a right triangle involving 36 degrees, from which we see that cosine 36 degrees is equal to AD over AB. And sine of 36 degrees is equal to opposite BD over AB. Okay. So these two are based on right triangle ABD. Okay. So to determine cosine 36 degrees, I need to know the exact value of the ratio AD over AB. To do that, we're going to use the fact that we have so many isosceles triangles here because of some angles being equal to each other. So I'm going to start with the following. I'm only interested in the ratios of the sides. So let ED equal to DC be equal to 1. Okay. How do I know that ED and DC are equal to 1? Well, I'm assuming it. Kunwari, ED and DC, each of them has length 3, then I'm just going to make the triangle smaller so that ED equals DC is now 1 when previously it's equal to 3. Ultimately, I'm only interested in the ratios of the sides as I try to find the cosine and sine of 36 degrees. So the legs themselves are irrelevant. What's important is how they are related to each other. So let me write down here in green, ED is 1, and then DC is equal to 1. And then now for AE, let AE, blue, let AE be equal to X. Okay.
Wait a minute. If I remember po correctly, some sort of there's this ano po alternate construction of a pentagon. It looks somewhat like that.
Related to actually, yes, it's related to 36. I think that could also be configured to determine cosine 36 degrees and sine 36 degrees. But this is what I remember. Now, Joshua, given those dimensions, can you help me determine the lengths of the, can we use that to determine the lengths of the other sides? For example, AB, the other orange one, BE, and then BC.
So AB is equal to 2 plus X.
All right, so let me write that in orange. AB is X plus 2 or 2 plus X.
It's also actually it's also the other side of the XX isosceles triangle, which is so x plus 2 over the sine of 72 is equal to x over the sine of 36.
Sorry, what's that again? What did you say? Sine of 36 or cosine of 36 degrees?
So x plus 2 over the sine of 72 equals x over the sine of 36.
X plus 2 over the sine of 72 degrees equals?
X over the sine of 36.
Yeah, I see you use the sine law.
Okay.
All right. However, you see, without knowing the value of X, we cannot really say anything specifically about sine of 72 degrees or sine of 36 degrees. So I wonder, is it possible to determine the value of X maybe? That's what we're going to try to do. Kasi EC is equal to 2. So maybe that will tell us how large X should be. Ganito. We have other dimensions here, other sides. Joshua, can you tell me, can we figure out the length of BE?
BE. That's actually supposed to be known. That's actually X.
Yeah, it's also X, right? You see that because of this 36 degrees and 36 degrees. Now next, what about BC?
Wait. That's also X.
Yeah.
Oh, we can also find the altitude. If we get the altitude, we can find X plus 2 in terms of X.
Yeah. We can do all that. Okay. The altitude, we can find out what it is. So actually, we can do it for the trig function values of 72 degrees. Okay, but ganito. Hey, because we have an angle bisector there. Okay, since BE bisects angle ABC, then what does the angle bisector theorem tell us?
X over 1 over x is equal to 1 over x. Wait. Uh 2 over x is equal to x over x plus 2. Hey. We can find the
Sorry,
value.
what's that? Ano yan? Say that again.
2 over x equals x over x plus 2.
Sorry, 2 over x equals x over x plus 2. So let's solve. 2x plus 4 equals x squared.
Squared, oh no. It's
X
equal to
squared minus 2x. And then we have 4. You can use a quadratic formula, but it's already x squared minus 2x. So why do we just add 1?
Oh, okay, good. Because I was wrong.
Okay. Now x minus 1 is 1 plus or minus the square root of 5. So x is 1 plus or minus the square root of 5. If you use the quadratic formula.
The golden ratio?
But which of these two is it? Do we have two possible values of x, or can we discard one of them? But note, if we discard one of them, we have to be justified in doing so. Hindi nung basta pumili lang tayo at random.
Since x must be positive. Oh wait. 1 minus.
Yeah.
1 minus square root of 5 is negative. Okay, good. Okay, so it must be, it's 2 times the golden ratio. It's actually 1 plus square root of 5.
Since x must be positive, then we must have x equal to 1 plus the square root of 5. So nakikita natin ang golden ratio dito, di ba? So now, this is what's going on. Now, if you look at A, B, D, where we have 36 degrees here, AD is x plus 1, but x is 1 plus square root of 5. So that means this is 2 plus the square root of 5. And then AB is x plus 2. So this hypotenuse is 3 plus the square root of 5. And we can solve for BD by the Pythagorean theorem. So BD squared is 3 plus the square root of 5 squared minus 2 plus the square root of 5 squared. So the first one you square it, 9 plus 5 is 14 plus 6 square root of 5 minus the square of 2 plus the square root of 5. 4 plus 5 is 9 plus 4 square root of 5. So BD squared is 14 minus 9, that's going to be 5. And then 6 square root of 5 minus 4 square root of 5 is plus 2 square root of 5. Which is the, yikes, kas nga lang, we want this to be convenient as far as taking square roots are concerned. At any rate, from the triangle, we can now already write down the cosine of 36 degrees. Okay, nung ano na lang ito.
Degrees, you can actually find the sine of 36 degrees just by using cofunctions.
Sorry, what's that?
Just use cofunctions po. Para if you get cosine 36 degrees, you can find sine 36 degrees.
Actually, but then in that case, you'd be relying on the Pythagorean identity. Diba? From sine squared plus cosine squared is equal to 1. At any rate, you would still have to grapple with this particular quantity. Okay. I don't know if I could simplify it in a much better way, but this tells us that BD is the square root of 5
Oh
plus
no,
2 square root of 5.
the rooting.
Hold on, let's see if we can make this nicer. 5 plus 2 square root of 5. Let's write this as over 2.
Can be the rooted.
So you have 10 plus 4 square root of 5. Kasi square root of 5 plus 2. Parang I don't think, or right now, I'm gonna leave it as such. So this means that therefore the cosine of 36 degrees from this triangle adjacent over the hypotenuse, 3 plus the square root of 5. Now, you know what? Let's rationalize this. 3 minus the square root of 5 over 3 minus the square root of 5. So this will give us, in the denominator, 9 minus 5. So that's 4. In the numerator, 6 minus 5, 1, and then 3 minus 2, so plus the square root of 5. So this is it. This is the cosine of 36 degrees.
The golden ratio over 2.
Yeah, oh, diba? Actually, in figuring out sine of 36 degrees, why don't we use this? We might have a better chance rather than having to deal with that ugly BD expression. Sine of 36 degrees, you're going to have to take the square root. Now, 36 degrees is in the first quadrant, so the sign is positive. So we don't have to worry about the plus or minus decision. 1 minus cosine squared of 36. So we square 1 plus the square root of 5 over 4. So 16 sa ilalim, no? 16 minus, and then 1 plus square root of 5, when it's squared, will give us 1 plus 5, 6, plus 2 square root of 5. The square root of 16 in the denominator is 4. In the numerator, 16 minus 6 is 10, minus 2 square root of 5. I think that's maybe as far as we go. Sine of 36 degrees.
Wait a minute. Isn't this like square root of BD over? It's in terms of square root of BD.
Yeah, there should be there should be BD over AB. So BD is the square root of 5 plus 2 square root of 5. AD is 3 plus the square root of 5. If you rationalize the denominator, that's what's going to lead to the 4 that we have done.
No, you need to deroot it.
Okay, but 10 minus 2 square root of 5, I have nothing specific as far as that's concerned right now.
Well, anyway,
Okay.
using this book, I found out you can technically get the sine and cosine of 3 degrees.
3 degrees, how so? Paano exactly?
So po, di ba po, 36 divided by 2, divided by 2. So we get to 9. If we divide by 2 again, 4.
Yeah. Actually, yes, you could do that. You could do half angle formulas. Actually, after all, I was talking about it kanina, di ba? From 30 degrees, you could go down to 15 degrees, 7.5 degrees. And so ito, sine 36 divided by 2, 18. Divided by 2, 9.
Divided
But
by
9
it will
is
become
4.5.
But then if we add that to 7.5, we will get 12. If we divide by 2 and then 2 again, we will get to 3.
I suppose, yeah. Or how about ganito? Kasi if you want three, if you want to explore the doubling, 3 times to 6, 6 times to 12, times to 24, times to 48. Tapos, no, never mind. Again, 48.
96.
Well, actually, ganito, 48 is 30 plus 18, di ba?
Opo.
So using the trig function values of 36, the sine and cosine of 36, you can use these to determine sine and cosine of 18 degrees.
Opo.
And then let's say you're interested in the sine of 48 degrees. So that would be the sine of 30 degrees plus 18 degrees.
So,
You can expand.
so ito
Kasi
nga,
parang ganun din.
opo. Ito
Uh,
po kasi yung question ko po eh. So, we have somehow reached yung, bito po. We have reached 3 degrees. So,
mhm.
how in the world would we get it? How in the world would we get it down to 1 degree?
To 1 degree. Let me know. Okay,
I just
1 degree.
up with 3.
Ganito, one, so isip tayo, if it's the result of dividing by 2, so can we target 2 degrees or 4 degrees, 8, 16,
32.
16, 32 degrees. So, well, think about it, Joshua. If you could try to find a way. It's not something I'm gonna shoot down because maybe who knows? I mean, I actually have, of course, never personally done this sine of 48 degrees, but given the strategy, I don't see why not. Now, it's gonna be tedious, pero yun lang yun, tedious lang. So you're just gonna one will only have to be really careful with the algebra in the same way that we ended up with sine of 36 degrees. All right. Okay. But that's a nice thing to consider, thinking of what can be done. Okay. Joshua, you are familiar with Huron's formula.
Opo, yung may semi-perimeter to get the area of
Yeah. Have you seen the proof of that?
Oh, it requires the law of cosine. I was just about to write po yung proof.
Sabi ko nga sa kanya po, so, sinasabi niya sa akin, I have proven before daw na yung proof ng Heron's formula. Can you write it? Kaya lang hindi niya nakalimutan niyang sulat kagabi.
Oh, sige. All right. So sige, if you've already seen how that can be proven, then I won't write it down anymore. All right. So and then you've applied Heron's formula na naman before, so that's okay. Or we are just doing some problem solving now. Ng mga graphs siguro ng trigonometric functions next time na lang. So I'm just running through.
Pero pasulot ko rin po para makita niyo po kung tama po yung niya po, yung approach niya po.
Sige. So ganito na lang. Okay. It's possible to prove it without trigonometry, but it just occurred to me because we are talking about the law of cosines. In fact, there are other consequences of the law of cosines. So Heron's formula, so nung semi-perimeter.
Why use semi-perimeter? Because does semi-perimeter have any other uses anyway?
The semi-perimeter, okay. I suppose if you want to stick with the perimeter, you could always just do P over 2. Tapos, the others would be P minus 2A over 2, P minus 2B over 2, and P minus 2C over 2. All right, that. So this, if we did not introduce the semi-perimeter, this is what it would have looked like. However, guided by the latter three fractions, Tama oh. Meron tayong 2a. It's so easy to divide that by 2. 2b easily divided by 2 and 2c easily divided by 2. So the thought is, what if we just divide the perimeter by 2? Then the formula would end up having a cleaner appearance. S minus A, S minus B, S minus C. So in the context of Heron's formula, using the semi-perimeter gives us a formula that looks nicer. And if it's nicer, then perhaps that would make it easier to remember. Now, there is another situation where the semi-perimeter makes an appearance. Ito, triangle in circle.
Oh no.
A circle drawn such that the three sides are tangent to it. Now, vertex A, B, and C. So let's call these X and X, Y and Y. So from B to those points of tangency, they're the same. So that's why we can use the same variable Y.
Nalaman niyo po bakit po nga? Kasi ano po, di ba kanina po nisasabi ko nga po yung mga Sadie circles.
Sorry, ano yan?
The points where the Sadie circles intersect either are tangent to each other are the points where the in circle is at.
Sorry, are you talking about the problem earlier?
Opo, yung earlier po nga if DEF has any relation with
actually it occurred to me, but I think it's different kasi
DEF po, ito po yung mga vertices of the in circle possibly.
No, if you're wondering, are in this figure are D, E, and F, are they the ano ba? Are they the wait, how was this drawn anyway? I forgot what this problem is. What are the conditions?
Sa taas po.
Iyon. So
There's only one set of Sadie circles per triangle. There's no other set of Sadie circles.
no. So what if D, E, and F are the points of tangency? All right. Actually, if they are, I think they would have to be the points of tangency kasi I'll get back to you on that next time. All right, but I think it just never occurred to me, but it might be onto something. Anyway, ito going back here. So we were talking about the semi-perimeter making an appearance kasi mangyayari nung y plus z equals a. Tapos x plus y is opposite c, so x plus y is equal to c, and x plus z is equal to b. So mangyayari if you add the left side, double x plus y plus z, you're gonna get a plus c plus b. That's the perimeter, which is 2 times the semi-perimeter. Also, that means x plus y plus z is actually the semi-perimeter, which means A is S minus X, C is S minus Z, and B is S minus Y. So in other words, X is equal to S minus A, Z is S minus C, and Y is S minus B. So itong mga nandito, itong X, this is S minus A, this Y is S minus B, and this Z is S minus C. So we're asking, where does the semi-perimeter make an appearance? This is one other situation that comes to mind. There might be others though.
Saka yung final po na question ko po, it may be it's just because it just looks similar. But if you connect the points of tangency of the in circle nga po, will they form the medial triangle?
Will they form the medial triangle? Sorry?
Yung mga tangents po ng the points of tangency of the in circle, will they form the medial triangle if connected?
The medial triangle, I think the medial triangle is what you get when you consider the medians. Okay. Median, so bisector nito. Okay, so iba. So kung kunwari, if this is the median, so if this is D, then that means BD equals CD. Pero this is a different situation. All right, kasi iba no BD from DC dito. Well, but basically, the midpoint D here is different from the point of tangency D on the right drawing. So it's a different situation.
Opo.
Anyway, for Heron's formula, this is all based on a formula that we have already seen before. A, B, C, the area. So the area of triangle ABC is this is small a, small b, small c. This is half of BC, BS, oh, BC times the sine of angle A. Remember that? We've done this before, right?
Opo.
So ngayon, if let's try to prove Heron's formula based on this. Now, Heron's formula does not involve the angle A. So that means we want to come up with a way of replacing sine of A using the sides. Now, the law of sines, if you want an equation involving sine of A, you have to use the sine of B. However, the cosine law allows us to write cosine of A in terms of just the sides. So let's use the cosine law. In particular, A squared is B squared plus C squared minus 2BC cosine A.
I remember that.
Right? Law of cosines. And what we have here is sine of A, but it's okay because sine of A, you can relate this to cosine of A via the Pythagorean identity. So in fact, ganito, let me square this. So we have 1/4 B squared C squared. Why am I squaring? So that I get to write down sine squared of A. Because I don't want to deal with square roots right now.
So
Then
that's why
sine
po
squared of
that's why po there's a square root sa Heron's formula.
oh, kasi nag-square muna tayo. In the end, we're gonna take the square root.
Opo.
Okay. Why did we square? Kasi ng sine squared of A, this is 1 minus cosine squared of A. Okay. From the law of cosines, let's solve for the cosine of A. Cosine of A is B squared plus C squared minus A squared over 2BC. Okay, so itong cosine A, we're gonna insert it here. So far we have 1/4 B squared C squared. Now ganito, I'm not too excited about squaring itong cosine A expression natin. Square that and subtract from 1. What I would like to do is 1 minus cosine squared of A. Let's factor this now. 1 plus the cosine of A times 1 minus the cosine of A. I don't want to do any squaring, but I'm sure if you square, you just need to be careful. It's just algebra. Ito. 1 plus the cosine of A starred expression, B squared plus C squared minus A squared over 2BC. In green, 2BC. And then in the numerator, we're going to have 2BC plus B squared plus C squared minus A. Minus A squared. And then what can be done with the numerator? Notice anything remarkable?
The numerator. Oh, B squared plus 2BC plus C squared is equal to B plus C squared.
It's a perfect square.
Oh.
So see what we have here? What we have in the numerator is the difference of two squares. Let's factor again. So now we have B plus C plus A, and then B plus C minus A.
Already. I see it.
All right. Let's do the same for 1 minus the cosine of A. Okay, but I'm sure you're able to see how it's going to be very similar. Okay, I already factored this because I was anticipating later on there would be a factorization that I would have to do. So rather than do that complicated square, which in the end I'm going to factor, I thought, why don't I factor now as soon as I get the chance?
Opo.
Ito, 2bc minus b squared minus c squared plus a squared over 2bc, that's a squared, minus the three first terms. Let's factor out a negative symbol from them. B squared plus c squared minus 2bc.
It's also again this perfect square.
But this is a squared minus the square of b minus c. So what do we now have as the factors of the numerator?
A minus B. Yeah, A minus B minus C, and then the other one will be A plus.
Well, a minus the quantity b minus c. So therefore, a minus b plus c.
And then the other one will become A plus B minus C.
All right, over 2bc. And this is what we now have times 1/4 b squared c squared. BC times BC is b squared c squared. It's going to kill this.
Oh.
And then so in the denominator, we have 4 times 2 times 2, which is 4 times 4, 16, 2 to the 4th power. Let's do this. A plus B plus C divided by 2, and then B plus C minus A divided by 2, A plus C minus B divided by 2,
Oh no.
A plus B minus C divided by 2. This is the area of ABC.
No.
And then with S as A plus B plus C, sorry, that's actually 2S. That's the perimeter. So if you consider, for example, B plus C minus A, that would be the result of taking 2S minus 2A. Okay, so that means ito, B plus C minus A, this is 2S minus 2A. Similarly, this is 2S minus 2B.
It's S and then times S minus A times S minus
Yeah,
B times S minus C.
and you have lots of those 2's canceling. S minus A, S minus B, S minus C. Heron's formula. Okay, this is something that you've already applied before, right?
Opo.
Nagawa mo na naman to, di ba? Okay.
Wow.
I think we can squeeze in a problem.
Prove the area po of prove the area po of the triangle is equal to the area of the triangle.
What? The area of the triangle is equal to the area of the triangle? Ito, example. In quadrilateral.
What? Quadrilateral?
A, B, C, D. 4 vertices, 4 yan nasa quadrilateral talaga. All right. AB is equal to 9. BC is equal to 40. CD equals 28. DA equals 15. And furthermore, angle ABC is 90 degrees. Find the area of quadrilateral ABCD.
I wish I could graph this, but I can't, unfortunately.
Okay.
So,
We have a right angle at B. So let's start with that.
is that needed po? Kasi if you have all 4 sides of the wait, is it is needed? But if
For
you
a quadrilateral, ganito, in a triangle, if the three sides are given, ano, that determines the triangle. Meaning, if you have three sticks, there is only one triangle you could form with those three sticks. However, given four sticks, assuming you can use them to form a quadrilateral, you can form many quadrilaterals
opo.
given four sticks. So the four lengths are not necessarily sufficient. They may not be enough. But with that additional information about ABC being 90 degrees, apparently that's enough to determine what the area is going to be. Ganito, and in angle B, we have 90 degrees.
We
So,
can find AC. We can determine two triangles, which we can just use Heron's formula.
mhm. Okay, A, B is 9. BC is 40, obviously not going to scale, all right? And then CD is 28 and then 15. Good. Find the area of triangle ABC. Suggestions or suggestion, game plan, strategy.
Find AC.
All right. And how would you find AC?
Pythagorean theorem, easy.
Yeah. All right. So tell me what
Oh,
AC
it's
is.
exactly 41. What?
Mhm.
Who thinks,
And
who
right.
comes up with these Pythagorean identity? Who comes up with these Pythagorean triples?
AC is equal to 41. And so now how's that going to help you? Kasi if this is 41, now you can use Heron's formula to determine the area of triangle ADC. Right? In triangle ADC, S is 15 plus 41 plus 28 over 2. So what's that gonna be?
I read this on the go and then I found out it's exactly 180. Who thinks of these problems?
Is it 42? Is it 42
Yung ano po? 41.
for the semi-perimeter?
Oh, the semi-perimeter is 45.
Oh, 45? 45? Double 45 is 90, but the perimeter isn't 90.
9 plus 4. Oh, ginagawa na po pala yung kabila. Bro.
Yeah, wait, I'm ADC.
I am so stupid to use the ano po,
No.
the Heron's formula when I could have just used 1/2 BH.
Oh, for ABC? It's a right triangle. Okay, so that's why I went straight to ADC. ADC muna.
42 po.
42, all right. So therefore, the area of ABC is in spirit of 42. And then 42 minus 41 is 1. 42 minus 28 is 14. What's 42 minus 15?
27.
27. All right. And then, well, 42 is 7 times 6. 14 is 7 times 2. 27 is 9 times 3. So when we take square roots, we have from 9, it's 3. From 7 times 7, the square root is 7. Then 6 times 2 times 3, that's 36. The square root is 6. So 21 times 6 is 126. And then, should we use Heron's formula on ABC?
Opo, use Heron's formula para ano po.
Yeah, use Heron's formula. So if you want to use 1/2 9 times 40,
180.
no! All right, 180. So therefore, we're done. For A, B, C, D, it's just 180 plus 126, 306.
How is it suspiciously clean? Who thinks of these problems?
I think, yeah. Okay, this is, I have other things that I've already planned for 5 p.m. onwards. So I'm afraid this is as far as I can go for today, Joshua and Sergio. So I hope you enjoyed.
Abo.
Okay, anyway, there are, nag-enjoy ka ba?
Abo.
All right. Okay. Have a good day.
Thank you
Bye.
po. Bye-bye
Thank you,
po.
sir.
Thank you po.
Bye.